given AE is equal to EC, congruent, and DE is congruent to EB, I need to prove that ABCD is a parallelogram. So what do I know? I know that you guys are congruent. I know that you guys are congruent. That's it. I need to explain that these are a parallelogram. Well, there's three ways really that you can show that things are a parallelogram, and none of them really have to do with the diagonals. But what they do have to do with are either opposing angles, consecutive angles, or opposing sides. I'm not given a ton of information about angles, consecutive angles, or anything like that. Consecutive angles would be like this whole angle A and that whole angle D. I'm not given any information about those. Okay, I'm also not given any information about opposing angles, which would be like that whole angle D and that whole angle B. So I'm going to do with the sides thing because I'm given a lot of information about the sides. So I'm thinking that since I'm given two, like the way this picture is set up is I have four triangles. I'm given the fact that these two sides are the same. These two sides are the same. These guys cross in the middle, so I can say that these guys are the same. I can say that, what color didn't I use yet? Red. These guys are the same. So if I can use SAS, 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 and SAS and prove that both pairs of triangles are congruent using SAS, then what I can do is I can prove that AD is congruent to BC and AB is congruent to DC. And I could use CPT, CT, CPP, CT, ICP for that one. Once I've done that, I can say this is a parallelogram. Okay? So let me start over. This is the green and blue is the information I'm given. All right? I could use vertical angles to show that the purples are the same and the reds are the same. Now that I have side angle side 4 times, I could say this triangle, the bottom triangle and the top triangle are the same. The left triangle and the right triangle are the same. And since they're the same, step number 5 or whatever, I could say that AD and BC are the same. And I could say that AB and DC are the same. And I could say that corresponding parts of congruent triangles are congruent. Now that I could say, now that I have information saying that opposing sides are congruent, that is using the opposite sides theorem converse to prove that this is a parallelogram. All right, hopefully I explained that well enough. This is, whenever I make a proof, I always make a rough draft off to the side. So there's my rough draft. So let me start out with my given. Always start out with the given, and that's AE is congruent to EC, and DE is congruent to EB given. All right, so I have 2 pairs of congruent sides of triangles going on here. I also have the fact that, let me use different colors. Let me use the colors that correspond. I also could say that AED, the measure of angle AED, what a shocking angle, and the measure of angle CEB, the measure of angle CEB, if I can write that correctly, they're congruent. Technically, I didn't need that little congruent thing if I'm saying the measure of angle, but I'm not even going to attempt to erase that. The measure of angle AEB is equal to the measure of angle CED. And this is the definition of vertical angles. Now that I said that, I have like a side angle side matches up with a side angle side. So I can explain that triangle, and we have to be careful with the order that we put this in. I'm going to go blue angle, blue, purple, green. So AED, the angle or the triangle AED is congruent to CEB in that order. And I can also say that DEC, the triangle, is congruent to BEA. And the reason for that is side angle side postulate. Since these two triangles, the lefty triangle and the righty triangle, are exactly the same, then we can say that AD is congruent to BC. And we can also say, since these triangles are the same, that AB is congruent to DC. And that was corresponding parts of congruent triangles are congruent. Last but not least, now that we have shown that opposing sides are congruent, we can say that ABCD is a parallelogram. And the reason for that was the opposite sides theorem's converse. Theorem converse. Opposite sides theorem converse, which says that if opposite sides of a quadrilateral are congruent, then you have a parallelogram. Okay? So there you have it. This is a way that you could prove that a quadrilateral is a parallelogram. The opposite sides theorem converse. You have opposite angles theorem converse, which is exactly the same thing, but angles instead of sides. And you have the corresponding sides, angles, I give up. The consecutive angles theorem converse. That one. And those are saying, if they're supplementary, then you have a parallelogram. Fun.